Hello everyone, I'm MD Ishtiaq Ashiq, and the other authors in this work are Weitong, Tobias, Fiebig, and Chung. So I'm going to present our paper, You Have Got Report, Measurement and Security Implications of DMARC Reporting. This is a joint collaborative work between Virginia Tech and Max-Planck-Institut. So this paper is about email security, so let's first start from the very basic and see how email works. So when you want to send an email, what you do is you go up to your mail user agent, you compose your email, and then you hit send. When you hit send, your MUA sends the email to your mail transfer agent, sending mail transfer agent via SMTP or HTTP. Your MTA then finds out the recipient MTA's address using DNS from the to header, and then send the email to that MTA using SMTP again over the internet. And finally, your recipient MTA delivers the email to the recipient's mailbox using mail delivery agent. So as is evident, SMTP is a very important protocol in email communication, so let's see how SMTP works. So in the very simplest form, SMTP has a series of commands, and as you can see, the sender sends some commands to the recipient MTA or the recipient. So for example, mail from here identifies the sender address, recipient to here identifies the recipient address, and after the data command, the whole email content is sent from the sender to the receiver. Now, one question that SMTP didn't have an answer originally is how can the recipient authenticate the sending domain? And the question, to answer this question, 3 protocols have been added to SMTP as a supplement: SPF, DKIM, and DMARC. How SPF works is SPF basically allows the receiving mail server to check whether the incoming IP address is authorized to use the sender's domain. So for example, here, the connecting IP from the sender is 192.0.2.3. So the recipient wants to know the answer to the question, is that IP authorized to use example.com as its mail from domain? So here, example.com sends an email to example.net, and then example.net looks up the TXT record of example.com over DNS and may find a value something like this. So this is called the SPF record, and as you can see, the CIDR IP that is allowed, that means that this particular IP 192.0.2.3 is actually allowed to send email using example.com as its mail from domain. So this is one form of authentication. Another form of authentication is DKIM, which is a public key cryptography based scheme. Works, again, like SPF, in this case, if the public key signature is okay, then DKIM results in a pass. For brevity, I'm going to refer this details of this DKIM to the paper. Now, one question that come up is what happens if SPF or DKIM validation fails? Now, problem is none of these 2 protocols actually tell the recipient what to do in case the validation fails. So to answer that question, DMARC comes into the picture. So here, for example, example.com sends an email to example.net, recipient validates SPF and DKIM, and both results in a failure. So in that case, example.net looks up the DMARC record of example.com and will find a value or tag called policy, P tag as we see, with a value reject. This means example.com is telling the recipients to reject the email if its SPF or DKIM fails. So in this case, recipient should not let this email pass to the user's mailbox. Another concept in DMARC is called reporting, as we can see in its name. So here we see the policy of example.com and we see an additional tag called the RUA tag with a reporting address or an email address. So in this case, the recipient can actually send a report to that particular address, and that report will contain some meta information like source IP, evaluated policy, results, number of emails within a certain span, and so on. Now this report will actually help the senders identify and address any spoofing attempts by the attackers on their domain. Will also provide domain owners with visibility in how email receivers implement and enforce the DMARC mechanism at their end. Now, these reports are XML formatted, so not very user-friendly. So more often than not, will domain owners delegate the reporting service to third party, and those third parties can process them and share the summary of the reports with the domain owners later. Now, coming back to DMARC reporting in the presence of external domain, com is here, the sender might have a reporting mail address that points to a different external domain like example.org here. And the question is, how does this recipient, before sending a report, know that example.net or example.org, in this case, the external domain, has agreed to receive the report on behalf of example.com? So this question has been answered by this concept called external destination verification, or EDV. So here, we introduce an additional authorization record at the external domain's end with a value v equals DMARC1. So before sending a report, example.net, the recipient should check for the presence of this EDV record and then should proceed to send the report to that external address. Another reporting that we use in the paper is SMTP TLS reporting. Compared to the DMARC report, which are sent by email receivers, TLS reports are generated by email senders. So here we see COM trying to send an email to example.net, but let's say there are some TLS misconfigurations or policy errors at the recipient's end, and that for that reason the email wasn't marked with TLS connection. So in this case, if the sender supports TLS reporting, SMTP TLS reporting, it should look up the TLS RPT record of example.net and may find a value similar to the RU tag that we discussed in the DMARC reporting address or DMARC policy. So this report will contain basically success and failure statistics with the receivers, which would be useful if the receivers want to fix their TLS configuration or MTSTS or DANE policy. Note that there is no external destination verification in case of TLS RPT. Now, from this background discussion, the research questions from a measurement point of view that we've addressed are how many domains use DMARC, how many of them use DMARC reporting, and how many receivers send DMARC reports. So let's see some of the results from a measurement dataset that we collected over a year for all the domains under COM, NATE, ORG, and AC zone. So the top graph shows the DMARC deployment ratio among these domains, which is about 8% and on the increase, as we can see. The middle graph shows that more than 50% of the DMARC-enabled domains have a reporting address in the DMARC record, and the bottom one shows the majority of those DMARC-enabled domains actually use external domains to receive and process the report. Now, even for popular domains, as you can see, DMARC deployment ratio goes down in popularity, but again, it paints a similar picture. We can see that majority of the DMARC-enabled domains specify external reporting address even for popular domains. Now, question is, how many of them do have the EDV authorization record in place, right? So right graph shows that nearly 20% of them that use external domains do not have EDV authorization record. So from this results, we question ourselves that how about the report senders? Because if it's not checked correctly, it can be abused to redirect reports. So from an attacker's perspective, the research questions we addressed in this research is, first of all, do SMTP servers in the wild have EDV check, or do they check EDV record before sending a report? And how about popular email hosting providers? And also, is the corresponding RFC unambiguously written for reporting? So what happens when there are duplicate email addresses in the RUA tag? Is there a limit to the number of addresses in the RUA tag? Overall, we wanted to see whether we can exploit these misconfigurations or ambiguities to launch a denial of service attack. So to test this out, we conducted several experiments, and here are a subset of experiments that we conducted to test few popular email hosting providers and open source softwares. So A.com is a domain controlled by us, and we set varying DMARC records as per each experiment. We subscribe to different email hosting providers and send them an email from A.com, and then we log all the incoming DNS queries and reports, which are analyzed later. So as we can see here, in the first two experiments, what we do, we check whether the report senders check for duplicacy if the RU tag contains mail addresses belonging to same domain or contains duplicate email addresses. In experiment 4, we set up another domain, B.com, again controlled by us, point the reporting address to it without placing the EDV DNS record at B.com. So we want to check from this experiment whether the popular email hosting providers check EDV record. And finally, in experiment 6, we check whether these providers support SMTP TLS reporting or not. So here are the results for the experiments. First 4 rows are for popular email hosting providers to which we subscribe to, and last 2 rows are to most popular DMARC reporting open source software that we know of. As you can see, except Fastmail and RSpamD, nobody else have the EDV check. So you can specify any arbitrary domain and they will send reports to it. And also there is no duplicate address check either except RSpamD. So you also see Google Workspace supports TLS reporting, which can be exploited as we will show later. Other 3 providers does not support SMTP TLS reporting. Here's the first attack scenario that we conducted. So attacker sends an email from his control domain, example.com to example.net. Example.net supports DMARC reporting. Now, if the attacker can have a DMARC policy, as we can see, where the RU tag contains same email address pointing to the victim that the attacker wants to target, and if Now the recipient, example.net, doesn't have VDB check and doesn't have any duplicacy check at all, is going to send M number of reports to the victim if there are M email addresses in that RUA tag. The formula for the amplification factor is this, where R is the report size that the victim received. 200 is basically an approximate number of bytes required to send a short email content from com to net to invoke this attack. And as you can infer from the previous slide, Google Workspace, Yahoo, and QQ, these three providers, they do not have VDB check and they do not have duplication check, but they support DMARC reporting. So we can actually use them as a reflector to launch an attack with an amplification factor of 1,000 times. Here's another attack that we leverage SMTP TLS reporting and DMARC reporting to circumvent the EDV check. So again, the attacker, example.com with his domain, sends an email to example.net, one of the recipients. Again, example.net supports DMARC reporting. Now the attacker can set a DMARC policy like this, where the RUA tag's email addresses points to his or her own domain. So if the recipient supports DMARC reporting is going to send a DMARC report back to example.com, the attacker can intentionally break their TLS configuration or strip the star TLS support, which will actually invoke a TLS RPT lookup by the recipient if the recipient supports SMTP TLS reporting. So, and in the SMTP TLS RPT policy, the attacker can specify as many as email or email addresses, different email addresses pointing to example.org, the victim domain that it wants to target. So in that case, the recipient are going to shoot M number of reports depending on if there are M email addresses to the victim. Again, the amplification factor is pretty similar. The difference is we can do this for each of the email addresses in the RUA tag of DMARC policy, so it's a quadratic amplification factor. And as we saw from the result earlier on, Google Workspace supports TLS RPT reporting, so we can use that as a reflector and achieve an amplification factor of 1,500 times. So to conclude, this is the first comprehensive study of the DMARC reporting ecosystem. We show that DMARC reporting actually holds the potential for annoying DOS attacks, especially against smaller operators. We also conducted a qualitative study to find out the scenario in practice, and we also have some recommendations in the paper for future iterations on RFC 7489, the corresponding RFC for DMARC. Thanks. With that, I'm happy to take questions.